Hey everyone! We have all been there, right? The brain fog after pulling an all-nighter? We know it just wrecks our memory, but a really fascinating new study shows it's not for the reason we've always thought. Okay, let's get into it.
You know that feeling? You stay up all night, and the next day you're not just tired, your brain feels broken, like you can't form a new memory to save your life. So what is actually happening? Why does just one single night of lost sleep have such a massive impact?
All right, so to figure out what's going wrong, we first have to understand how it's supposed to work. Let's take a look at what your brain is doing on a good night's sleep to save all those new memories.
See, when you're asleep, your brain isn't just off. Not at all. It's actually running this super important background process called memory consolidation. It's basically taking all the fragile, temporary files from your day and saving them properly to your mental hard drive, turning them into memories that'll stick around.
And the headquarters for this entire operation? It's a little seahorse-shaped structure deep in your brain called the hippocampus. You can think of it as your brain's own personal librarian, working the night shift to sort and file away all the important things that happened to you that day. Okay, so we have our library, the hippocampus, but how does it actually, save the files? Well, our little investigation now has a prime suspect. And here they are. Meet sharp-wave ripples, or SWRs for short. These things are these incredibly fast, high-frequency bursts of activity. The leading theory is that each one of these little ripples is basically your brain hitting the save button, rapidly replaying a recent experience to carve it into your long-term memory.
And this right here, this is what that save button actually looks like to a scientist. You're seeing the electrical fingerprint of a sharp-wave ripple. Each one of those dense, little lightning storms of activity is a tiny, fleeting moment where your brain is physically writing a memory into its code. It's wild.
So this leads you to a pretty logical conclusion, right? If these ripples are the save button, then a sleepless night must just mean you're not hitting save as often. Fewer ripples equals fewer memories saved. It makes perfect sense. But is that actually what's happening?
And this, my friends, is where our detective story takes a huge twist, because when the researchers actually looked at the evidence, what they found completely flips the script on how sleep loss messes with our memory.
The data from the lab was crystal clear and totally surprising. That simple, obvious answer was just plain wrong. The problem isn't the number of times the brain is trying to save the memory. Okay, now take a look at the actual data here. The researchers compared the brains of well-rested rats, that's in black, with sleep-deprived rats, in red. And what's just mind-blowing is that the sleep-deprived brains were firing off just as many, and in some cases even more ripples, than the well-rested brains. So the key point is, the brain is hitting the save button over and over again. The quantity isn't the problem. Something is going desperately wrong with the quality of the save itself.
So if the brain is trying to save but failing, what is the real culprit? It turns out the issue isn't the quantity of the ripples, it's the quality. It's about what's actually inside those save files, or, more importantly, what isn't.
Now, to really get this, we need to understand the crucial difference between two terms, reactivation and replay. Reactivation is just getting the right group of brain cells to fire. Think of it like all the actors for a movie scene showing up on set. They're all there, which is a good start. But replay, that's when those same actors deliver their lines in the correct sequence. It's the difference between a jumble of neurons and a coherent memory. And here's the first piece of damning evidence. This graph tracks how strongly those memory-related neurons are firing. The black lines show the healthy, sleeping brains. Notice that signal stays pretty strong. Now, look at the red line from the sleep-deprived brains. The signal is weaker right from the start, and it just fizzles out way faster. The brain is literally struggling just to keep the right actors on the set.
But this slide right here is the smoking gun. This chart measures how many of those save attempts actually contained a real memory, a true replay. In the well-rested brains, you see a nice, consistent number. But look at that red bar for the sleep-deprived group. The number of actual, coherent memory replays absolutely plummets. The brain is hitting the save button, but the file it's trying to save is corrupted, garbled, or just plain empty.
So this leads us to the final and maybe the most important question for anyone who's ever pulled an all-nighter. Can you just fix the damage? Can you get a good night's sleep the next day and catch up?
While the results here are pretty sobering, after a night of recovery sleep, that basic reactivation, just getting the right cells to fire, it does rebound a little bit, but it never gets back to normal levels. And what about the crucial part, the high-fidelity memory replays? They don't rebound at all. It seems that once that window for saving the memory closes, you can't just go back and do it later. The the damage appears to be lasting.
So, what's the big takeaway from all this? Sleep isn't just passive downtime for your brain. It's an active, essential period of hard work. It's when our experiences are carefully rehearsed and filed away, becoming part of who we are. And as this research shows, it's a critical job that simply cannot be put off until tomorrow.